Hello everyone. In this video, we'll be seeing the third problem on Hasse diagram. Let us take this question. Let B be the given set. So, the given set is B is equal to 2, 3, 4, 6, 12, 36, 48. And S denotes the relation defined on B by division. So we can write the relation S as set of all. We know that clearly 2 divides 2 and 2 divides 4, 2 divides 6, 2 divides 12, 2 divides 36, 2 divides 48. Next one, 2 doesn't divides 3, we should not write it. Similarly, 3 doesn't divide 2. We should not write that part also. 3 divides 3, we can write it. 3 doesn't divide 4. So 3 comma 4 entry we should not include here. So next one will be 3 comma 6, 3 comma 12, then 3 comma 36, comma 3 comma 48. Next one, it is 4 comma 4 and 4 doesn't divide 6, we should not include it. 4 comma 12, 4 comma 36 and 4 comma 48. Next one, it is 6 comma 6, 6 comma 12, 6 comma 36, 6 comma 48, and then 12 comma 12, 12 comma 36, 12 comma 48. So next one is 36 comma 36. Next entry will be 48 comma 48. So first we are going to draw the directed graph. That is directed graph for the given relation. So 2 and 3 are the minimum elements here, and 2 and 3 they are not related to each other. So we can place 2 entry at one place and the next entry 3 at another place. So next one is 4. Clearly 2 divides 4 and there is no relation between 3. I am going to fix 4 at this place. So next one, 6, it is there, and 2 and 3 commonly divides 6. So we can place that element 6 here. If we see 12, all these entries 2, 4, 3 and 6 will divide 12. So we can keep that 12 at the middle of these things. Next one, 36 is there. Every entry will divide 36. So we can put 36 at this place, and 48. 36 doesn't divide 48. So we should not put 48 above the place 36. We have to put 48 at the place similar to 36. Now we are going to draw all the edges. Clearly 2, it is related to 2, it will be here. Then 2 is related to 4, so this entry will be there. 2 is related to 6, this entry it will be there. Then 2, it is related to 12, so this entry it will be here. Then 2, it is related to 36, so this entry will also be here, and 2 is related to 48, this entry will also be there. Next one, we have to start with 3. Clearly 3 is related to 3, we are going to put it here. 3 is related to 6, and then 3 it is related to 12, we can take this one, 3 to 12. Then 3 it is related to 36, we can put 3 to 36. Similarly 3 it is related to 48, so 3 to 48. Next one, we can come for 4. 4 is related to 4, so this entry will be here. Then 4 to 6 it is not related, but 4 to 12 entry it is possible. Then 4 to 36 it is 4 to 36 it is possible, and then similarly 4 to 40 8 also it is possible. Then starting with 6, 6 to 6 is there, 6 to 12 it is there, and 6 to 36 it is there, 6 to 48 entry is also there. Starting with the 12, 12 to 12 is there, 12 to 36 it is there, 12 to 48 it is there. Next one 36 to 36, next one 48 to 48. So this is the directed graph. In next step we have to remove all the self loops. So remove all the self loops. So we are going to remove it. Place all the entries at the same. So it will be 2. Here it will be 3. It is 6. Here it will be 12. And here it is 36. Here it will be 48. Now removing self loop, we can write or draw all the edges. So 2 to 4, 2 to 6, 2 to 12, 2 to 36 it is there, and 2 to 48. Next one 3 to 6, 3 to 12, then 3 to 36, then 3 to 48. And then starting with 4, 4 to 12, 4 to 36, 4 to 48. Starting with 6, 6 to 12, 6 to 36, 6 to 48. Starting with this 12, 12 to 36 is there, 12 to 48 is also there. Then 36 self loop we have removed, 48 self loop we have removed. In next step we have to remove all the transitive edges, that is to remove all the transitive edges. We can place all the entries. So here it is 2, here it is 3, here it is 4, here it will be 6, middle part it is 12, and here it is 36, here it is 48. So we know that 2, 4 entry we have to draw because there is no transitive edge between these two things. And then 2, 6 also we have to connect. In any other way we cannot connect this part. Next one 2, 12. If I want to come from 2, 12, already 2 to 4 is there and 4 to 12 edge is also possible. So I can come in this way. Then 2 to 36 we can come like 2 to 4, 4 to 12 and 12 to 36. Next one for 2 to 48 we can come in this direction 2 to 4, 4 to 12 and 12 to 48. So next starting with 3, 3 to 6 there is no yet. So we have to draw it 3 to 6. And then 3 to 12 we can reach in this way. So 3 to 6 and 6 to 12. 3 to 6 and 6 to 12. 3 to 36 we can reach from 3 to 6, 6 to 12, 12 to 36. 3 to 48 also we can reach 3 to 6, 6 to 12 and 6 to 40, 12 to 48. Next one starting with 4. 4 to 12 it is possible. 4 to 36 is possible. 4 to 48 is also possible. Starting with 6. 6 to 12 is possible. 6 to 36 is possible. 6 to 48 is also possible. Starting with 12. 12 to 36 is possible. 12 to 48 is also possible. So this is the reduced diagram. In next step, we have to remove all the directions, that is upward notations. We are going to remove all the directions. So let us place all the entries. So this will be 2, 3, 4, 6, 12, 36, 48. So our reduced diagram will be this one. So this is the required Hasse diagram. So Hasse diagram is used to represent a partial order relation in a simplified manner.